We click on stuff on our computers all day long, thousands of times, and we never really think about it. But today, we're going to take that one simple action, a single click, and we're going to follow it down the rabbit hole. We're peeling back the layers to see the incredible, hidden world that just explodes into action underneath. I mean, really think about it for a second. You click a program and poof, it's just there on your screen. It feels instantaneous. It feels like magic. But it's not magic. It's this breathtakingly fast, super complex chain of events. So what is the secret story that's happening inside your machine? Well, that's exactly what we're here to find out. All right, to start this journey, let's look at the part of the system we all know and see, the applications themselves. This is the world you interact with every single day. But even up here on the surface, there's a really strict set of rules about how everything is allowed to talk to each other. So the first thing you have to understand is that an application can't just do whatever it wants. No way. It has to make a formal request to the operating system, kind of like asking for permission. It does this through something called the Windows Application Programming Interface, or API. Just think of it as the official language, or maybe the gatekeeper, that translates what the app wants into actions that Windows can actually understand and carry out. And honestly, this restaurant analogy is perfect for understanding the whole relationship. The application, you're the customer. You know what you want. The API is the waiter. It takes your order and makes sure it gets to the kitchen correctly. And Windows, that's the kitchen. It's the powerhouse in the back that actually does all the heavy lifting. This separation is absolutely crucial for keeping everything running smoothly and, more importantly, securely. Okay, so our application gave its order to the waiter, the API. Now what? Well, that order has to cross a major boundary. Think of it like a digital velvet rope that separates the everyday world of your programs from the super secure inner sanctum of the operating system itself. And this idea of separation, it's one of the most fundamental concepts in all of modern computing. It's a security model, and its whole purpose is to protect the core of the operating system from any app that might be buggy or even malicious. It creates these two totally distinct zones that have very different levels of power. And here they are, user mode and kernel mode. Pretty much every application you run, your browser, your games, everything lives in user mode. It's called non-privileged, which is just a fancy way of saying they have really limited access and they can't mess with your computer's hardware directly. But the core of Windows itself, that runs in kernel mode. This is the privileged zone. It has total unrestricted access and power over everything. So the big takeaway here is, for an app in user mode to do anything important, it has to ask the kernel for help. Seriously, the best way to picture this is like a concert. All the apps in user mode are out on the general admission floor. Kernel mode, though, that's the secure VIP backstage area. To get from the floor to backstage, a tiny piece of the program, called a thread, uses a special command that's basically its VIP pass. This lets it jump into that privileged space just long enough to get its job done, and then boom, it's sent right back out to the floor. So we've made it past security. We used our special pass, and now we are officially backstage. We're inside the kernel itself, which is the true heart and brain of the entire Windows operating system. If you think of an application as maybe a single musician in an orchestra, the kernel is the conductor of the entire orchestra. It's managing every single resource, every program, every piece of hardware, just making sure they all work together perfectly. And its to-do list, as you can see here, is just immense. It is constantly doing things like thread scheduling, which means it's deciding which one of thousands of tiny little tasks gets to use the processor at any given nanosecond. It handles interrupt dispatching, which means reacting instantly when you press a key or move your mouse. It is a non-stop, unbelievably complex job of managing absolutely everything. Now, I know what you're probably thinking. This all sounds incredibly abstract, right? Like it's all happening in some hidden world we can never actually see. But that's not entirely true. We can actually peek behind the curtain, and we can do it using a tool you already have on your computer right now. That's right, good old Task Manager. Now, it's not going to show you everything that's going on, but it is a fantastic little window into all the processes and activities happening in user mode, that first part of our journey. And getting it open is super easy. The book Windows Internals actually lists 4 official ways to launch it. The fastest is probably just hitting Control-Shift-Escape, but really, any of these will get you there. If you're at your computer, go ahead and pop it open now. Okay, so here is a fantastic piece of trivia. This comes directly from our source material. The name Task Manager is technically wrong. The Windows kernel doesn't actually have a concept of a task. Internally, it works with things called processes and threads. It's just this little quirk that kind of shows you the layers of separation between what we see and what's really going on under the hood. So when you open up Task Manager and you look at that big long list under the Processes tab, you are looking directly at the residence of user mode. Every single one of those entries is an application or a service running in its own protected little sandbox where it can't interfere with other programs, and each one is constantly making requests to the kernel to get its work done. So there you have it, from a simple click to an API call, across that great divide into the privileged kernel, and then all the way back out to draw a window on your screen. And it all happens in the blink of an eye. It really is like a silent orchestra, which I think leaves us with one last thought. If this much complexity is hidden behind a single click, what other invisible, intricate systems are quietly powering the world all around us?